All right. So we finished making our student classes. Okay, so we've got our student header where, again, that's where we're keeping all, like, where we're saying what the class is going to have and do, but we don't say how we work with any of this stuff. But in the student CPP file, this is where we actually say, okay, here's the code for this function, here's the code for this function, here's the code for this function, and you'll see we're also playing around with the attributes that belong to the class. And then here, this in my hello world file, this is where I have my main, where I guess I've created an instance of a student. I made a copy of a student. I got a string from a student. I checked if students were equal. And of course I was good, so I deleted the students. That's that. Now we're gonna make a more complex thing. So we're gonna make a course class. Oh, I heard something. We can't see code. Oh my goodness, I just said, oh my goodness. I'm so bad at this. You'd think I'd have it together by now. All right, let me say that again. So in our main, this is where we're creating instances and telling them to do stuff. But of course, we can create objects not just in the main. We can do it in other areas. And our student header, like I was saying, we define the attributes and we declare the attributes and we say what the functions are going to be. And here in the CPP file, this is where I actually write the code for the function. Oh, I heard another boop. Let's see, move into chat. Is that a meth lab in the background? I didn't know that we were in Canso. Oh my god. That's not very nice. Okay, and then we saw that, okay, well, here, I'm gonna create a new class called a course, and I'm just gonna take all this stuff, because we're gonna define this, we're gonna write it. I know there's a lot in here that I threw at you, but we're gonna write it here. So first, right click. Is my computer alive today? Whoop. Let's see, add a new class. And what did I call it? Course. Give it a second. And so we've got our course header here. Oh, I guess I already had it. All right, strange. So here's the course header. It's got all the stuff I said it was gonna have. Again, we saw this weird thing with like a student pointer. And here's some of the functionality. And let's get rid of that. Okay. And then in course CPP, this is of course also where we will write the code. All right. Okay. So this is where we start. And let's start with some constructors. A default is just to prepare the object for us and have an array with some default value. And then we're gonna have the not default value constructor. How bad is that? How bad is that saw sound? Try to turn down my gain a little bit to see if it only picks up my voice. Let's see. Give me a second. Hopefully, well, let's make it negative 15. Maybe that'll help. Oh, nope, definitely do not want to close OBS. All right, so yeah, do tell me if you can't hear me over the saw. We can still hear you regardless, but there is a lovely sound of a saw drilling through tile. Yes, okay. All right, so we're gonna build our constructors. Our default, our not default, which will basically be the same thing, but I guess we'll just start with like a starting array size, and then we'll have our copy constructor and a deconstructor. But we're going to want to probably do our copy constructor later, kind of once we get a sense of how things are going to fit together. So here's the default constructor. I'm just going to go here, copy this because I'm super lazy, and let's talk about what's going on. So from course, the constructor, nothing in here, it's the default one. By default, we're going to make our object, the number of students it's going to start with is 0. Oh, did I not have these? Oh my goodness, look at this. Well, I'm bad. These should, of course, have this in front of it, but guess I'm not doing that here. So, okay, here's our our default constructor, number of students, course starts with nobody in it. The class is going to be, remember, this is a pointer to a bunch of student pointers. So it's going to be equal to an array of student pointers. Okay, that checks out. And then array max is going to be whatever the default capacity is. Array max is the information. This stores how big the array is. Like if the array is size 10 and I have 10 students in it, well, my course is at this point full. Like that array is full. Then I go here, and it's basically the same thing. The only difference is, instead of using the default capacity, I use whatever the size is. So default capacity, I had it set to 10. That's just an arbitrary number. Maybe you know that, well, my class is gonna, or my course is gonna have like 100 students-ish. So let's start with a course with 100 in here, and then there. It makes the array of size 100, and the array max is 100. Copy constructor, we're going to come back to that. And actually, we also are going to come back to the deconstructor because, again, we're going to want to talk a little bit about how we should delete stuff. Or at least how to tell C++ how it should delete a course. We're going to come back to these. Okay, add. This is going to be easy. Here's what we're going to do. Now, we actually do have a design decision to make here. And one is not better than the different. Or one is not better than the other. The way I'm doing it is, this function that I'm about to write, add, is going to take as parameters all the information it needs to know to create a student object. Then I'm going to make the student object, add a pointer to that student object to the array, and then add 1 to the number of students there are in the class. The alternative is to write, and I could overload the add function. Oops. I guess I showed you something here. Okay, I could overload the add function such that, like, well, we could create the student somewhere else and then have add just take a pointer to a student that it puts into the array. But I guess I've made the decision here to, no, this object will create a student, or this function will create a student object. Now, tell me if this makes sense to you. All right, course add. It's going to take a first name, a last name, student number, an email, and an average. And then immediately it's going to create a student pointer called toAdd, and then create a new student with this information. I'm basically just passing the information this function got along to the constructor of a student. Then after that, I say my class at numStudents, make it equal to toAdd, and we'll talk about this in a second. And then down here, we're going to say, okay, number of students plus plus. This is just, okay, well, we've added 1 student to the class, so the number of students we currently have needs to increase by 1. Now, you might be saying, why are we indexing at numStudents? Well, actually, this is a convenient little thing we've got here. The fact that numStudents, let me put it this way. When you have no one in the class, numStudents is 0, right? Then, when you want to add somebody, it needs to start at index 0, right? So if there's no one in here, this is index 0, 1, 2, 3, 4. If there's no one in this array, numStudents is 0, there's currently no students in there. And then if I were to come along and create a new one and say, okay, my class at numStudents, which is 0 in this case, equals add, well, that goes here. And it'll point to some student somewhere. Then we're going to increase the number of students. And then if I were to call add again, well, okay, we create a new student object somewhere in memory. I don't know, let's say it's right here. And what are we saying? Well, numStudents. Well, numStudents is now 1. And then we can just set that to whatever toAdd is. Okay, fantastic. So numStudents is actually kind of doing double duty for us. It's keeping track of how many students there currently are in the class, but it also keeps track of the next available spot for a student to go. Because we'll just keep building our student class like from 0 up. Okay? But of course, you might see a problem with this. There is actually, you know what, before we talk about the problem, I'm gonna make sure we understand what's going on here. So we create a toAdd. It's a variable here. And inside of it, we create a pointer to a student object. Let's say I'm adding a third one, okay? Great, so toAdd is this. And then immediately I say, okay, not my class at num students, well now it's 2, will be equal to 2 add. So we're going to copy over whatever the contents of this is. Remember, equals is always copying over the contents of the variables. So what's the contents? Well, it's a memory address, OX something, 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 which again, it's just a pointer to a student. So if we copy this over, well, this will become that memory address, a pointer to that new student. So that's why it works. You might be saying, well, hold on. Why didn't you delete it? I mean, whenever we see that, whenever, we create a new student, whenever we see this new keyword, we should delete it. You're right, but we don't want to delete it now. We want to delete it once we're done with it. But presumably, if we've added this thing, like if we've added a pointer to our array to point to the student, we don't want to delete it yet. We want to keep track of that information. We're going to want to delete the student later. Spoiler, in the deconstructor. Now, there's of course also, should be deleting at the end of the method since I have, oh yeah, I just answered that. Can anyone think of the huge problem with this? Let's see, type in the chat if you can think of the problem. Let's see if I can erase all this. Ooh, I can erase everything on the slide. Aha. No one has any idea what is wrong with this. Oh, I hear some boops. What do we got? Maybe the array size is already declared, so it might make a memory leak. No, that's not what I'm thinking. But if the array is full when you try to add a student, there could be an issue. Yes. Oh, yeah, and Felix, yes, you're totally right. You're totally right. What happens if I have an array of this size and it's full? I don't know. These are all students. I'm just drawing circles now because I am that lazy. All right, fine, we can add bodies. All right, so we've got in here, the max size in this scenario would be, so I'm gonna say max size is 5 here because the array is size 5. 1, 2, 3, 4, 5. And num students is also set to 5, or not set to 5, it is 5 because we've got, although we had 5 spots, that's what max is, they're all full. So that's why number of students is 5. If we try to come along and add a new student at index 5, well, index 5 is right here. And this has not been really allocated to us, has it? We're gonna have a bit of an issue. We're going to be writing to RAM that wasn't allocated in this array. We have a huge problem. So how can we solve this problem? Does anyone have any idea how we can solve this problem? And I realize half the people that in the class that were at the lab yesterday have an idea. Allocate more, exactly. How do we do that? Well, at no point can we allocate, at no point can we change the size of our array. When we make an array of size whatever, it's stuck. Forever, that array is always going to be that size. That's the way it is. But how about this? Maybe the solution is, okay, instead of making the array bigger, just make a new bigger array and copy everything over and then delete the old one because we don't need it anymore. Well, that's what we're going to do. We're going to use this expand capacity function or method. This is the private method. This is the method that any code like in the main or outside of this class should not have access to this method. And the reason is this is just a helper method for the class. This method is only ever going to be run from within the class, namely the add. So here's what I'm going to do. We're going to take whatever the array size is, let's say it was 10 or 5 in our previous example, double it and make that the new array size. There's a good reason we always double, but we'll learn about this later. But the point is, you can see it's twice as big, it's bigger. And then what we're going to do is create a new student pointer array. All right, pardon me, a student pointer array called new class. And it's there we go. But you'll see it's based on array max, which is now twice as big as the original array max. So let me draw what we got here. So currently we have, I don't know, what was the variable called? My class, which is a pointer to this array. 1, 2, 3, 4. That was full of pointers to people. Okay. Then what I did, oh, and then array max was equal to 5. So then what I said is, no, you're not 5 anymore, you're 10. Then you're going to create a new thing called new class, which is going to be a pointer to a new array of 1, 2, 3, 4, 5, 6, 7, 8, 9, great, of twice the size. Okay, so this is what we have so far. Then what I'm going to do is create a loop that starts at 0 and goes up to number of students. Okay, why number of students? Well, number of students should be whatever the original array max is. So here, if we're ever expanding capacity, if we ever need to make the array bigger because we run out of spots, well, I only need to look at the 1, 2, 3, 4, 5 things here. So what I'm going to do is say, okay, new class at location I, you are equal to my class at location I. So what's my class at location I? Well, starting at 0, 1, 2, 3, 4. Well, it's a pointer to a student object. So copy that over, and that'll be a pointer to the same student object. I'm going to actually try to change my color here. There. Let's see. I hear a question. Allocate more. Wait, was that the question? Did I not hear a boop? Or is there a secret? Did someone give me a secret chat message? I don't know. Oh. Maybe that was a secret. You shouldn't all see. So there, and then we copy, like I becomes 1, and then we go, and then I is 2, copy it over, I is 3, copy it over, I is 4, copy it over, and then we stop because it's less than num students, and num students was 5, right? So we stop. And then we have 1, 2, 3, 4, 5, 1, 2, it's tiny 1, 3, 4, 5 bits that are for, I mean, they're the new area. Then we're going to want to delete what my class points to. So when we say delete my class, also mind the fact that we've got the square brackets here because that's, it's an array, my class. We're gonna delete what this points to. Remember, we're not deleting this variable. We're deleting what's at the memory address in this variable. So this says, okay, go along and like, you don't need this anymore. We can deallocate that. It's gone. This is garbage. We don't need it. Because we're safe, because the things that were in here that were pointing to some students are now accessible through the new pointers or the copied pointers in the new array. And then we're gonna say, okay, my class is now new class. So my class, you're now equal to whatever contents of this variable is, which happens to be the memory address of where this is. So this becomes that. Great. Two things. We do not want to delete new class. Because remember, when we are deleting, we are not deleting the variable new class belongs to. We are not deleting what's in the memory address where new class is. We're deleting, when we call delete, that means delete what this points to. And if we delete that, I mean, we now have no array anymore and we've completely lost track of our students, so we're in bad shape. Another thing too, you might say, why not do this before? Well, if you did this before, what would happen? We would have our old array, and then we've got our new array. But if we said my class points to this now, we suddenly lose reference to this. Like we don't have a pointer to this anymore. And now this is a memory leak. We cannot delete this anymore because we cannot access it. We have no reference to it, pointer to it. So we're in trouble. That's why we want to delete, we want to assign the things after we delete. Suppose I'm going to just double check what that someone messaged me about in case it is important. All right, okay, that question I'll look at later. In fact, to the individual that sent me that question, send that to me in an email, otherwise it'll get lost and forgotten. Not because I don't like you, but because that's how my brain works these days. No boop. Well, there was a boop, it was just a hidden boop. Okay. Oh, look at that, I already showed you. Make a new one, new class, make it point to that, copy these over, and then you delete that and now assign it to the same thing. We're happy. There. See? And you should all be very impressed by my drawing skills. Look how happy these people are. They're not lost. Actually, this person seems indifferent and this person seems sad, but that's okay. All right. So now we will modify our add method slightly. You'll see that, okay, this is the same as before. Create a new student object and then have a pointer to it. Then we're adding it to the position that it belongs in and then increase the number of students. But what we're gonna do is this. It's just If the number of students happens to be equal to the maximum size, well, then we have to call expand capacity. We need to say, okay, just you need to double your size. This is the only place expand capacity will ever and should ever be called. I'm going to copy this code because this is the code I want. And course.cpp. And here we go. And you know what? Because I always like using this, I'll do that. So create a new student. If we're out of space, we better make more room for it. And then put the student where it belongs and then increase the number of students we added. That's it. That's it. It might seem like a lot, but you'll notice that kind of once, like by breaking this problem down, like how do we add a student? We'll break it down into its like atomic units. Suddenly it's like 1, 2, 3, 4 things. That's it. Create the new one. If we're out of space, make new space. How? Well, we wrote the code for it. Actually, I didn't yet. Let's, there. Now we've got the code for expanding capacity. There. And so if we run out of room, make a bigger array, and then add the student, increase the number of students. Awesome. Cool. Now, let's test so far. Always good to test. So what am I doing in this test? Well, first I'll copy it over and then we'll talk about it. And I've got a drawing there, I guess. So maybe actually we should talk about it on the slide before I get to it. Whoa. Oh my goodness. Okay. I'll go back here. So what are we saying? Well, all right, so we have a pointer to a course object. So we're creating a new course of size 5. And I'm gonna add 1, 2, 3, 4, 5 students. We've got, so here's what we have. We have the variable C, which contains the memory address of where the course is stored in memory. All right, and I'm representing the course as this oval. And then within the course, we have a couple of attributes. We have my class, which is a pointer to an array of student pointers. We have a default capacity, an array max, and a num students. And right here, right between this line and this line, this is the state right here. This is the state right here. And you'll see we have my class, which now has 1, 2, 3, 4, 5 things in it. Perfect. If we run this, I mean, this is what we, like, if we run this, this is what we should get internally. But of course, this test isn't actually, like, I can run this code, but, there, I'm gonna run this code. First I'm gonna build it, then I'm gonna run it. And then when I run it, you'll see that like, okay, did it do anything? Because we won't know. I mean, we're not outputting anything. We don't really have a nice, clean, easy way to interpret whether or not this is correct. So I'll just show you. Oh, failed. What did I do wrong? Oh, I'm calling the deconstructor and it's not declared. Scalar deleting constructor unsigned int. Shoot. I guess I'm gonna have to add these. Let me, nope, not those. There. We'll go here. And we have to say there. This, I think this will make it shut up. Otherwise, I'm in trouble. All right, we're in better shape now. Okay, I hit run. And I mean, nothing happens. Like we haven't done anything. So I think a good thing to write next is the toString, because if we can run this code and then ask our course object to give me a string version of itself, then I'm in good shape. Because then I can just print it out and it should match what I expect. So now what that should look like, I don't know, but let's have a look at what I suggest in the slides. So we're writing our toString. So this is, you know, this is called like string building. Start with an empty string. And then what I'm gonna do is I'm just gonna say like, okay, for like basically iterate over the my class array and just get the string version of each individual student and append it to that string. And then in the end, return the string. In fact, I'm going to modify this slightly. Actually, no, I guess I'm not, because I don't have really any other attribute here to include. Okay, I'm gonna modify this toString slightly. The modification doesn't matter at all. I'm just gonna do it for fun. So I'm gonna go down here. I like to add my toStrings near the bottom. And I'm gonna do like number of students plus std toString of num students. Whoop. There. So what am I going to do? Well, instead of starting with an empty string, I start with the string number of students colon space, and then I add this to it. And then I guess I should also add a new line. Plus slash n. There. Maybe I'll do 2 new lines for readability. And then I'm going to say, okay, student object that's pointed to by the thing at my class at index 0, what's your string? And that toString, the student's toString gets called. This right here. This function gets called, and it returns the stringified version of that individual student, that instance of a student. And then I will become 1, and so on. So we will ask each individual student, okay, give me your string. And then I'm going to take the student object's toString to build my course's object's toString. Why don't we need to specify which toString we are using? Because it's context sensitive. In fact, we actually are really telling it which one it's using. The toString is the one written that's relevant for whatever this is. And this is going to be a pointer to a student object, so it's calling the student's toString because it knows that this is a student object. If I had something like, well, I can't really show an alternative right now because I don't have anything more. The arrow? The arrow is because the reason we have the little arrow is because, well, my class is like full of student pointers, right? And because it's full of student pointers, I need to dereference it. And you might remember that the arrow is the same thing as that. It's like the arrow is a shorthand for doing all this. So the dot is when the thing you have is the object, and the arrow is when you are too lazy to write out all the syntax for dereferencing. It means, okay, dereference and then access this this method from that class. And then there's a third thing in there. Do we not need to include the CPP, which has the methods for the student? And are all languages that smart? What? Oh, you mean in terms of knowing what it is? Well, yeah, because they'll be context sensitive. It'll know, yeah, the languages will be smart because it's not even that it's being smart. It's really not even saying like, oh, I know I should be calling the toString method that belongs to this class. It's not doing that. It doesn't even care that there's another toString being written here. It doesn't care that there's a method anywhere else in the code called toString. What it really means is, okay, from the class, from this specific instance, that is a student object, call the function within that, defined within that class called toString. And that just means this. So it's not really even connecting any dots about, like, oh, I need to go find the right toString. No, really what it's doing is it's just finding the toString from this, like that belongs to this. It might be a useless distinction, but I'm putting it in. Do we not need to include for the student? Do we not do the method? Where? You mean here? Because
I just meant, yeah, like, excuse me. We just have like include student.h, which is the header file,
yeah.
But aren't all the methods and stuff for like on a student.cpp file?
You're right, but what it looks for is just the header, because it's going to be like, well, this is telling me what's there, and that's a case of, I guess, it's being smart enough to know that, like, well, in the CPP file, that's where all really is. But this is what
Okay.
tells us. I mean, we can start talking about things like how the compiling works and linking works and all that. We're not going to. Really, this is telling, like, C++ when we're writing the code, like, this exists, trust me, and then when it's running, it's going to be able to find it. But this is like telling us that, like, yes, you have access to this stuff. You know that it exists, and when we compile it, we're gonna put all this stuff where it needs to be in order for this to work properly. So hopefully that answers your question. There is no parameter for both toString functions, though. Well, yes, because this well, hold on. This standard one, there is a parameter here. The standard library's toString took this parameter. This one doesn't take a parameter because, well, let's go look at the toString method written in the student object. Look, it doesn't take any parameter. There's no parameter. If here I had a student object, right? And I were to write something like s toString, and then I'm going to do the exact same thing, but turn this into a C. These are different toStrings, but again, it goes back to what the other guy was asking. Who was it that asked that? Yeah, so about all the languages being smart. Well, it's not that it's going and being like, oh, which toString am I running? It's going, oh, from S, go look up the toString. And what's the type of S? Well, once we dereference it, it's a student. So this is going to go look into the student CPP and run this function. Why? Because it belongs to the student objects. Then here, when I say, okay, on C and you dereference, that's not a student object. That is a course object. So it's going to go to the courses and go, okay, I'm going to run this code because this is the toString for the course. So we named our function the same as the standard library. Yes, but it's not named. But like that's what we. Okay, hold on. We gotta slow down here.